Hello, Charan. Hello, Sushant. How are you?
Fine, sir.
Well, Sushant, I sent the notes, okay? You can just arrange it in the order. And mechanics part, actually, there are the first few class was on the vector, okay? So those class notes are not downloadable now. So that's why I sent it from the kinematic part, okay? Hmm. Okay, and for you, I'm going to send it the chapter wise the question paper, okay, for your practice. Okay, so just now after the class, I will send it. Okay, from there you can practice the questions. Okay, it's arranged in the chapter wise. Okay, and topic subtopic wise. So those questions are objective type. You can practice it. Solve examples are also there in that one. Okay, so you can solve the questions from that material. Mm. Okay, let's just wait for a minute and then we will start. Okay, till then I am sending you the questions from electrostatics part. Okay. Okay, everyone check electrostatic 1, 2, and the current electricity. These three topics are there in that. Yeah, same way for the mechanics part also, I will send it. Actually, can we start? Null and Lokesh not yet joined. Okay, let's continue. I think they will join. Okay, so we were discussing about the force part, है ना? Different type of forces. What is the magnitude and direction of these forces? That is what we were discussing in the last class. Okay. So, right. This is where we finished our last, okay, isn't it? The force calculation. Okay. The type of forces we discussed, right? What are the different type of forces we discussed? Normal reaction. Okay. Next one was the normal reaction is what kind of force? It's a pushing type of force, you know? It always try to push the body which is in contact. Next force we discussed was the tension. It always pulls the object. And the okay, let's just start now. So force part we have discussed now till now, right? Up to normal and tension. These two type of forces we discussed in the last class, isn't it? And we have to discuss about the spring force now. So can we continue now about the spring force? Please tell me. Everyone, please tell me, understood up to the tension force? Please tell me, the direction of tension force, it is always what kind of pulling in nature. The tension force is what? Pulling in nature. Hello, hello. Please check it. Is my audio video is clear? Hello.
Yes, sir.
Right. Okay. Let's continue now. Okay. So let's start. So we were discussing about the next type of force, which is the spring force. Okay. So spring force, what is the property of a spring force? It can be what? It can be pulling type as well as the pushing type, isn't it? Depending on what? Depending on whether we have elongated the spring from natural position or compressed it. See, what is the direction of a spring force? Tell me. The direction of a spring force is what? It is always towards the natural position of a spring. What is the direction of a spring force? Direction of a spring force is what? It is always towards the natural position of the spring. Okay. So one thing please keep in mind, direction of spring force. Spring force is what? Force is towards towards natural position of the spring. Okay, which position? Natural position of spring, meaning is what? If you elongate the spring or if you compress the spring, what is the spring force will try? It will always try to bring the object towards where? To the natural position of the spring. Let's say something like this. Let's say I am going to put or I am going to elongate the spring by something x. Please tell me which direction the spring force is going to act on the block. Just tell me the direction first. Please tell me what is the direction about which the spring force will be acting. Can I say the direction of a spring force is going to be towards the natural position? So this is the direction of what? Spring force. And spring force is what? Spring force is variable in nature. Variable in nature means what? How much spring force is applied on a block, that not only depend on what is the spring constant, it also depends on what is the elongation or compression we have produced in the spring. Okay, so that's why spring force is what? K into x, where k is what? K is the spring constant and what is x? X is the elongation or compression in the spring. Is that clear? Please tell me. So the magnitude of a spring force is what? Magnitude of a spring force is kx. And what is the direction of a spring force? Direction of a spring force is always towards what? Always towards the natural position of the spring. Okay. So here if you see that, is the spring is trying to pull the object now? Please tell me. Is the spring is trying to pull the object right now? And if you push it, if you push the block towards the wall, then what will happen? The spring will push the block again, isn't it? So that's why spring force is what? It can pull the object as well as it can push the object, depending on what? Depending on what has been done with the spring. Is the spring is being elongated or the spring is being what? Compressed. Is that clear? Please tell me. Please tell, understand up to this what we have discussed about the spring force. So spring force magnitude is equal to kx, and the direction of spring force is what? The direction of spring force is always towards the natural position of the spring. Natural position is what position? The position when spring is neither elongated nor compressed. That position of a spring is called as what? The natural position of the spring. Every spring has what? A natural length. Understood? Please tell me. Clear up to this? Next, let's please tell me. Clear up to this? Let's take an example and try to understand the direction of a spring force. Okay? Let's say I'm going to give you a question like this. Here, instead of one block, I am connecting the two block. Okay? This is the block 1 and this is the block 2. It is kept on the horizontal smooth surface. Okay, where it has been kept, it is kept on a horizontal smooth surface. Right now the block is in what? Spring is in what? Spring is in natural condition. Understood? Now what I am going to do it, I am going to pull these blocks away. Means block number 2 is moved here and the block number 1 is what? Moved here. Understood? This one is called the natural length of spring. This is called what? The natural length of spring. And from the natural length, the total elongation produced, na, that is given x. So can you tell me what direction spring will be applying the force? Can you answer it? What direction spring will be applying the force? Please tell me what direction spring will be applying the force on the block number 1 and on the block number 2. On both the block, tell me the direction of spring force. Please tell me. Can I say block 2 will be pulled towards its natural position and block 1 will be also pulled towards it? Please tell. Is this part clear?
Yes, sir.
So that means you can see whenever a spring, a single spring is connected with two blocks, does it always apply equal and opposite force on both the block? Tell me, what will be this spring force? Same as this spring force, okay? Because it is an ideal spring, and in case of an ideal spring, what will happen? The spring force throughout the spring will remain what? Same. So how much is going to be the spring force in this case? The spring force in this case is going to be K into X, where X is what? K is what? K is the spring constant, and X is what? X is the total elongation. Understood? Here, K is the spring constant. Okay? K is what? The spring constant. And the next one, X is what? X is the total elongation produced in the spring. Okay? Total elongation in the spring. Now, please tell me one thing. What are the factors on which K depends? Please tell me. Stiffness of a spring will depend on what factor? Can anyone tell me? Factor affecting the spring constant. Tell me. So spring constant of any spring, na, it depends on three factor. Okay? It depends on what? The three factors. What are those three factors? K is what? Directly proportional to area of a spring. Area means what? The spring whose cross section area is more, na? That will be more difficult to elongate or compress. Understood? Spring constant. Spring constant tells us what? How much force is required to elongate or compress the spring? So more the K, more difficult it will be, na? So that's why K is what? Directly proportional to area of a spring. It is inversely proportional to length of a spring. See that which spring is easy to compress? The smaller one or the bigger one? Please tell me. It will be the bigger spring which will be easy to compress or elongate. And third one, it depends on the property of material. What is A here? A here we have is the area of cross section of a spring. Okay. L is what? L is the length of a spring. And what is Y representing? Y is actually Young's modulus of material. This spring must be made of some kind of material, na? Maybe steel, maybe iron, maybe copper or aluminium. Okay, so every material has different Young's modulus of what? Modulus of elasticity. Okay, Young's modulus of what? The elasticity. So a spring constant of a spring depends on three factors: area, length, and what? Young's modulus. Is that clear? Now comes sometime we have seen that the springs are connected in such a way that it is called series combination of a spring, and another case it is called parallel combination of a spring. Okay, so what will be the condition for combination of a spring? When do we say that these springs are connected in series, and when we call it is connected in parallel? Tell me. Combination of spring, tell me. The combination of a spring means what? There are two type of combination possible. Okay, series combination and parallel. What happens in series? In series, let's say two or more than two springs are connected. So they will be connected in such a way that the force acting on each spring will be what? Equal. Understood? Something like this. If you see here, see that this is the spring number one. From here, there is another spring connected like this. And after these two springs are connected together, that is connected to a block. Understood? Then these two springs are connected with a block of mass m. This is K1 and this is K2. You see that when you will elongate this block, isn't it the same force will produce in both the spring? So that's why these two will be called as what? These two will be called as the series combination of the spring, or we will say these two springs are connected in series combination. So in series combination, if I want to replace it by a single spring, so what I will do it? I will use K equivalent here. Understood? So in series combination, what is going to be K equivalent? To 1 by K equivalent equal to 1 by K1 plus 1 by K2 plus 1 by K3, like that. So if two or more than two springs are connected in series, what will be their equivalent spring constant? 1 by K equivalent equal to 1 by K1 plus 1 by K2 plus 1 by K3. And the second type of combination will be what? The parallel combination. What remains same in the parallel combination? Please tell me. Anyone can tell what is the same thing in the parallel combination of a spring? Please tell me. X remains what? Same. X means what? What does it mean by X? X means what? Springs have springs which are connected in parallel. When do we call these two springs are connected in parallel? If springs are having same elongation or compression, same elongation or compression, right? then we call these springs are connected in what? The parallel to each other. Understood? When do we call them parallel? If they have the same elongation or compression, then what we can say? These, see that. Now, if you elongate the spring, what will happen? If you elongate the spring, what will happen? Same elongation will produce in K1 spring, and same elongation will be produced in what? K2 spring. So that's why these two combination will be called as what? Or these two will be called as combined in what mode? They are connected in parallel mode. So what will be the equivalent spring constant in case of parallel combination? So K equivalent will be K1 plus K2 plus K3 plus K4 like that. Understood? Please tell me. So how many forces we have learned till now? Please tell me. How many forces we have learned till now? Gravity, right? Normal, tension, and spring. These are the four forces we know till now. The next two force which is going to come in this chapter is going to be what? Going to be the friction force and the pseudo force. Okay, but we will discuss about these two forces later. Before that, let's first focus on the problems where we have to solve it for these four forces. Okay, clear? What are these forces? Right now, whatever question we are going to take, in those questions, either gravity will be involved, normal force will be involved, है tension will be involved, and spring force will be involved. Friction and pseudo force, will discuss it after finishing the question of these topics. Is that clear? Please tell me.
Yes, sir.
There is one more example of parallel combination. Please tell me what is that? This is an example where many of you will get confused. See, have you seen this question? This is K1, this is K2, and this mass M is connected. What is the combination here? How these two K1 and K2 are connected? Series or parallel? Don't only look at the diagram, look at the condition needed for series and parallel. Look at the condition needed for series and parallel. Tell me, what is the condition needed for series and parallel? The elongation or compression should be same. Understood? So please tell me, is it a series combination of a spring or parallel?
Sir, parallel.
Yes, it is a parallel combination. Why? Because let's say if you elongate by x distance, what will happen? K1 spring will be elongated by x. It will apply K1x force. K2 spring is compressed by x. So it will apply K2x force. And check it. Are these two forces is the same direction? Please check it and tell me. Isn't it? Because this was the position, which one? This was the natural position for both the spring. And now we have extended in such a way that what is happening? They are getting connected and they are getting what? K1x and K2x force in which direction? In the same direction. So this is also what? A parallel combination only, right? K equivalent will be how much? K1 plus K2. Understood? So that's why be careful whenever you get a question of a spring combination. First of all, decide it, is it a series combination or is this a parallel combination? Clear? Please tell.
Questions will be like advanced type of questions.
Mm-hmm.
Will the questions in AP will be like advanced level, I mean the J advanced question type.
No, 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 no. No, not JEE advanced level. It will be around JEE mains only, little bit less than JEE mains only, but not beyond that one. Okay? Not JEE advanced. JEE advanced question, if you see that, that is completely different. Okay? So
Yes,
your AP exam will not have the advanced level question, JEE advanced level question, but more or less up to JEE mains level questions you will have. Okay? So that's why I gave this material for you to solve it. Okay, solve it. Then we will have the some previous year paper also. You can check it, whatever the uh, past papers of this your AP exam. Then you can see that it's not very difficult questions. We are going to have it in the final exam. But prepare it all type of questions. Okay, please tell me, is this part clear? Now, whenever we are applying the force on a body, there are going to be two possibility. Can you tell me what are the two possibility we are going to have? Please tell me. Whenever we are going to apply a force on a particle, then there are going to be two things happening with the particle. There are two possibilities, not two things. The we have applied the force. See, sometimes we are applying the force, body does not move, na? Body does not accelerate. Listen, sometimes the forces are acting on the particle, but still it doesn't have any kind of acceleration. The reason is what? The forces are balanced. Understood? The equilibrium of particle means what? Acceleration is what? Zero. Understood? When do we call a particle is in equilibrium? When acceleration of particle is zero. Okay? When net acceleration of a particle is zero, we call the particle is what? It is in equilibrium. Okay? So what will be the requirement for particle to be in equilibrium? So the moment we know the equilibrium of a particle, that means acceleration is zero. And what does acceleration zero tells us? Does the acceleration zero tells us that net force should be zero? Because acceleration is force by mass. If acceleration of a particle is zero, that means what? The net force acting on that particle should be also zero. And net force, when we are writing, can we write it? Net force in x direction is zero. Net force in y direction is zero. And another thing, net force in what? Z direction is also zero. So if net force is zero, that means what? If you want to make net force zero, sometime only one direction is involved, you made that net force is zero. But sometime in the question, what will happen? There will be two direction involved in the question. So we have to make net force equal to zero. In which direction? In both the direction. If three directions are involved, then we have to make net force equal to zero in all three directions. Is that clear? Please tell me, understood the equilibrium of a particle? And what about the acceleration of particle? Please tell me.
Yes, sir.
So when do we call there is going to be acceleration of a particle? Please tell me. So if I want to know the acceleration of a particle, that means what? If a particle has acceleration, means if acceleration is non-zero, that means what? Can I say net force equal to what? Mass into acceleration. अब again, if net force in the x direction, if I do the comparison, है ना? Net force in x direction, if I do the comparison, that gives me mass into acceleration in x direction. If we write net force in y direction, that gives us mass into acceleration in y direction, and net force in z direction gives us what? Mass into acceleration in z direction. Okay, so whenever the forces are not aligned in only x or only y or only z, what we do? We should take the component to bring it in what? X and y and z. Okay, if it is equilibrium condition in the question, we will make these net forces to be zero. If acceleration is there, then we will make net force equal to mass into acceleration. This is what we will do it. Now let's discuss the questions on that. And one more theorem is there for equilibrium, that is called Lamis theorem. Heard about it? But we will apply this theorem only for what? Only for equilibrium of a body. Okay, Lamis theorem, it is for what? For equilibrium of the particle. Okay, What is the Lami's theorem for equilibrium of a particle? Generally, we apply Lami's theorem when the particle is in equilibrium under the influence of three forces only, okay? Not more than three forces, because if more than three forces will come, it is always better to take the component, okay? If more than three forces are involved in a question, it is always better to take the component method to solve the question instead of what? Instead of using the Lami's theorem. Understood? So what is the Lami's theorem? Lami's theorem is a very simple one. Let's say this is a F1 force, there is a F2 force, and this is the F3 force. So from a point on the body or from a point on the particle, three forces are acting. These forces are making some angle also. Let's say this angle is alpha, this angle is beta, and this angle is what? Gamma. So for equilibrium, what is the condition needed? For equilibrium of particle, what is the condition needed? So see that F1 force you look at. What is the angle in front of F1? So if this is the F1 force, the angle in front of F1, is it alpha angle? Right? F1 is making beta angle, gamma angle with the other two forces. But what is the angle in front of that one? Alpha. So we will write it F1 divided by sine alpha equal to. Look at F2 force and tell me what is the angle in front of F2? Is it beta? So sine beta. And in front of F3, what is the angle? It is gamma, isn't it? The sine gamma. This theorem is called as the Lami's theorem for equilibrium of the particle. Only we can apply if equilibrium of particle is maintained. And another thing about this condition is what? That the three forces should be there, not more than three forces. If more than three forces comes, with better to apply what? Component method. Okay, so let's discuss few examples. One two example we will solve it using the Lami's theorem method. Then we will also discuss some questions on component method. So please tell me, up to this part is clear? Everyone joined the class or not yet? Yeah, still one is absent. Manal is still absent. Okay, please tell me, understood up to this what we have discussed?
Yes, sir.
Please tell me.
Yes, sir.
Please tell everyone, clear or
Yes,
not?
sir.
Yes, sir.
Right. Now let's discuss some examples now, how we will get the question based on the equilibrium. Okay. In this question, what is given to us? Right. There is a question given. There is a ceiling here given to us. From the ceiling, there is a string connected here. Okay. There is one more string connected through this wall. Okay. Mass of the block is given as 10 kg. Okay. The mass of block is given as what? 10 kg. And this angle is given 37 degree, and this is horizontal string. Okay. Achha, do you know the value of sine 37, cos 37, and tan 37? Please tell me the value of sine, cos, and tan 37 and 53 degree. Please keep in mind this triangle. Okay, right angle triangle. This right angle triangle. This is a right angle triangle. This angle is 37 degree. This
7.
angle is 53 degree. So smallest angle, smallest size, medium angle, medium side, biggest angle, biggest side. Okay, this is called 3 4 5 triangle. Okay, so sine 37 is how much? Sine 37 is 3 by 5, cos 37 is 4 by 5, and tan 37 is 3 by 4. So just keep in mind this one. Why? Because sometime when they give the angle as 45 degree, na, the root 2 will come. If I give you angle 30 degree, so sine 30 to 1 by 2 will become, but cos 30 root 3 by 2 will come. So calculation look little bit bulky. That's why instead of giving you the angle as 30 degree, 45 degree, 60 degree, they will give you 37 degree. Because if you take 37 degree, sine and cos both will give us a very nice value. Okay. So here what you have to do it in the question, find a tension in both the string. So these two are two different string, na? Please tell me. Find a tension in both strings. Okay. Let's find what is the tension in both the string. Can we apply the Lamis theorem here? We have to start with drawing the free body diagram. Okay. Start this question with what? The free body diagram. Please tell me what are the forces will be acting. 10 kg object is there. So 10 into G means 100 Newton is the mg acting. This string I am going to call it as the string number 1. Horizontal string. This string is what? Horizontal. So what will happen? This string will be pulling the block. And a string always does what? String always pull the object, isn't it? So string 1 is trying to pull the object. Now look at this string 2. This black color string. See that? What this one will be trying to do? Is it also trying to pull it? Please tell me.
Yes, sir.
So these are the three forces are there. What are the two unknowns? T1 and T2, which we have to calculate it. What are the angles? Tell me. This angle is 90 degree horizontal and vertical. Check it. This angle is 37 given. So this alternate angle will become what? The 37. So that means we know what is this total angle. Is this total angle is 90 plus 37? Isn't it? 90 plus 37. And what is this angle? This angle is 180 minus 37. Please check all the angle carefully done. This angle is 90 plus 37. Green color angle is 180 minus 37. Now let's apply the Lamis theorem because this block is in equilibrium. Na? This block is what? This block is in equilibrium. So whenever the equilibrium condition satisfied, what will happen? Either the component method will work or Lamis theorem will work. Okay. Please tell me what I should write it. Should I write it if I want to solve this question further? Should I write T1 divided by sine of 90 plus 37? T2 divided by what is the angle in front of T2? 90 degree. 100 divided by what is the angle in front of 100 Newton force? Sine of 180 minus 37. Now we will simplify it. Okay, now I'm going to use this one and this one. Okay, so tell me how much it will come. T1 sine 90 plus 37, is it cos 37? Equal to 100 divided by sine 180 minus theta, that is the sine theta itself. है ना? Sine 180 minus theta is sine theta. Sine 90 plus theta is cos theta. So what is the T1 we are getting? 100 into cos 37 divided by sine 37. So what we are getting answer? 100 divided by tan 37. And what is the tan 37? Just check it. Tan 37 is 3 by 4. Right? Tan 37 is 3 by 4. So what is the T1 value we got it? 400 by 3 Newton we got it. How do we get the T2 value? Please check it and tell me. So see, if I want to know the T2, should I use this one and this one? Any other combination also I can use it, but can I use that also? It gives me the same result, isn't it? So please tell me what I will get it. T2 divided by sine 90 is 1. 100 divided by sine 180 minus 37, sine 37, right? So we have T2 equal to 100. Sine 37 is 3 by 5. So what is the T2? We got it 500 by 3 Newton. We got it. Please tell. Understood this one or not?
Yes, sir.
Please. So here what we did, the body was in equilibrium, so we applied the condition of what? The equilibrium. Please tell. Clear?
Yes, sir.
Yes, sir.
Right. Okay. Let's discuss another example. Okay. In this example, what is given to us? A fixed sphere is given to us. Okay. A fixed sphere is given to us. The question gave there is one block M1 here, and there is a string connecting M1 and M2 here. Do you understand the question? This is M1 block, this is M2 block, like this. And this is a fixed sphere, okay? Matlab fixed sphere you can consider, or you can consider a fixed cylinder is there, okay na? And they are asking, what should be the value of theta? Do you understand the question? Question they are asking, find the value of theta. Find the value of theta. Smooth surface. Right now, I am not yet considering the friction condition. Okay, I'm all considering the smooth surface. Find the value of theta so that this arrangement, okay, this arrangement can stay in equilibrium. This arrangement can stay in equilibrium. Understood? What should be the value of theta so that this arrangement can stay in equilibrium? This is what they are asking. Okay. Please tell me what should happen here. So please tell, is it M1 is also in equilibrium and M2 is also in equilibrium? Can you draw the free body diagram first? Please tell me. Can you draw the free body diagram of M1 and M2 separately? Chaliye, let's draw the free body diagram of M1. What are the forces will be acting on M1? Can you answer it? What are the forces acting on M1? Can you tell me? Is there going to be M1G acting in the downward direction? Will there be a tension? You will say, sir, how the tension will be acting? This string is a curve one. Yes, this string is a curve one. But this string is connecting the M1 at this particular point. Na? So at this particular point, how the tension will be acting? So can I say at this point, tension will be acting tangent direction of that point? Isn't it? At this point, if I try to draw the tangent, isn't it this is the tangent will come? So this is the T. Can you tell me what else will be acting? Will there be one more force? Normal due to the sphere will be acting. Please tell me. Are you clear about these three forces? Please tell me. So that means what is the equilibrium? Please tell me. So for equilibrium of M1, can I say T should be equal to M1G and N1 should be equal to, tell me an interesting thing you are going to learn it here. N1 should be coming to what? 0. Can you tell me what does it mean by normal coming 0 in the calculation? Or what does it mean by if I am getting the calculation, doing the calculation, and after calculation I am getting that normal is coming something negative, 0 or negative. What does it mean? So whenever you calculate the normal value in a question And if you get it 0 or negative value, that means simply there is no contact exist at that point. Okay, whenever we calculate the value, and if we get the value of normal as 0 or normal value, let's say by chance I am getting it as negative, that means what? There is no contact between the two bodies. So whenever two bodies leave their contact, so at that time what happened? The normal between them becomes 0. So actually this diagram should be how? Please tell me. Is it the correct diagram? No. Can you tell me how this diagram should look like? This diagram should look like this. Just let me draw it one more time. Actually, can I say this M1 block will have a slight gap here? Please tell me. Do you understand why I'm calling there is a gap here? Because I calculated the normal and I got the calculation of normal as 0. So that means that is telling me that there is a gap, means M1 is, there is a small gap between M1 and that fixed cylinder. Understood? Please tell me. Now let's focus on the M2. Please tell me, can we focus now on N2? Please tell me. So M2 free body diagram, if I draw it, can you tell me what forces will be acting? Again, M2 into G will be there. Please tell me, is the M2 is in contact here? Just check it once. Is the M2 has a contact with this cylinder? And is this angle theta? Just check the same diagram. Whatever is this portion, na, I have just drawn it here for you. Check it. Have I drawn all the angles carefully?
Yes, sir.
Lines carefully? Now tell me, what is the normal due to cylinder? Is the normal due to cylinder will come something like this, perpendicular to contact surface? And tension will be which direction? Is the tension is going to be along the tangent at this point? Please tell me. अब here if you see that tension is along the tangent, normal is along the normal. तो मतलब these two are already perpendicular to each other ना? And you see, if this angle is theta, can I say this alternate angle also theta? So N2 and T are already perpendicular to each other. So isn't it? That means I should take the component of M2G now. Please tell me. Because, or what else you can do it? You can directly apply the Lamis theorem also. See, na? Three forces are there, angles are known. We can apply the Lamis theorem also, or you can apply the component method. Okay. I'm going to solve this question using the component method. So what will be this component of M2G? So M2Z cos theta है ना? This component is with the angle. So M2Z cos theta. And what is the other component? M2Z sin theta. Now for equilibrium, what should happen? Please tell me. What is the condition needed for equilibrium of this M2 block? So for equilibrium of M2 block, can I say N2 should be equal to M2Z cos theta. That is the one condition. And other condition. This is the first equation. Second equation. T should be equal to M2G sin theta. And what we just calculated the value of T. The value of T we have calculated is M1G. M1Z. So M1G should be equal to M2G sin theta. Isn't it? So what is the sin theta we are getting? Please check it. G and G get cancelled out. M1 by M2. Understand the value of theta? Please tell me, what is the sin theta we got it? Sin theta we got it M1 by M2. So if sin theta comes in such a way that if sin theta comes as M1 by M2, then what will happen? This arrangement can stay in equilibrium. If sin theta equal to M1 by M2 is not fulfilled, then what will happen? They cannot remain in equilibrium. Understand the second question of equilibrium? Please tell me, clear about the second question of equilibrium?
Yes, sir.
Right. Let's discuss one more example on the equilibrium. In this example, what is given to us? There is a spring here. A spring constant is K. There is a mass M hanging here. After that, there is one more spring there. Its spring constant is 2K. And here the mass hanging is 2M. Understand the question? Matlab, one spring is there. Okay. A mass M is hanging. The other spring is there. Mass 2M is hanging. They are asking in the question, find elongation in both the spring. Understood? Find the elongation in both spring. How much it is going to be? One by one, we have to calculate it in the question. And it is in equilibrium. Okay, na? Because it's not moving anywhere. Now find the elongation in both the spring. In what? In equilibrium condition. Okay. So please tell me, what is the condition required for equilibrium? What is the condition required for equilibrium? Net forces should be 0. So let's start with the free body diagram of 2M. Okay. Let's start with the free body diagram of 2M. Can you tell me what forces will be acting on 2M? One will be 2mg. है ना? Can we say that? One force which is acting on the 2M is 2mg. Can you tell me what is the other force acting on the 2M? So to balance that, can I say there will be a spring force acting on that? What will be spring force? 2K into, can I say that? 2K into, let's say L. What is L? Please tell me, what is L here? L is the elongation in the 2K spring, okay, or second spring. Now tell me, for equilibrium, what is needed? Please tell me, for equilibrium, what is the condition needed? So for equilibrium, can we say that 2KL must be equal to 2mg? Please tell me. Can we say here, for equilibrium, 2KL must be equal to 2mg? So what are we getting? 2 get cancel out. What is the L we got it? mg by K we got it. Please tell, clear the elongation in the 2K spring? Now we will draw the free body diagram of M block. So please tell me, M block free body diagram, what forces will be there? 1 mg will be there, right? Now please tell me, how many spring force is acting on M block? 1 or 2? Look at the block M and tell me how many spring force is acting on the M block? 1 force or 2 spring force? Please tell me how many spring force is acting on block
One.
M. Block M I am asking. See, block M is in contact with the 2 spring. The 2
Two
spring
spring.
force will be acting now. So
Yes,
1
sir.
spring 2K. So you see 2K is applying force on 2M. So see that. See carefully. That's why I took that example of direction of a spring force. See, if you look at 2M, is the spring force on 2M is like this? So on the M, can I say the spring force will be like this? Please tell me. If on the 2M, 2M mass, spring force is like this, so on the M mass, can I say the spring force will be like this? So one spring force acting on the M block is 2KL. Now, to balance that, does it need one more spring force? Please tell me. And what will be that? K spring will be applying that. And how much is that? K into L dash. Understood? Now let's write the equilibrium condition one more time. KL dash will be equal to 2KL plus mg. So KL dash equal to 2K. What is the 2KL? Please tell me. What is the 2KL? 2KL is the 2mg plus mg. So what is the L dash we are getting? L dash is coming 3mg by k. So elongation in the k spring is how much? 3mg by k, and elongation in the lower spring is how much? Mg by k. Please tell me, understood? So these are all the equilibrium questions. I am going to send the questions for you in the mechanics part also, okay? Which you all try to solve it, okay? For electromagnetism, I have sent the questions, okay? Please tell me, for electromagnetism, I have sent the questions to, okay, electrostatics part. So same way, I'm going to send you the questions for the mechanics part also, okay? So
Okay.
please start solving the practicing the questions from these topics, okay?
Okay, sir.
Right, everyone? So let's meet it on the Wednesday now and continue it from here, equilibrium. Then we will discuss about the acceleration question also. And then we will go for the friction force, okay? Not now. First, acceleration and equilibrium we will discuss for without friction cases, okay? So let's meet it on Wednesday, okay?
Yes, sir.
Right.
Yes. Thank you, sir.
Thank you. Thank you, everyone. Take care and please solve the questions, okay? I'm sending the questions. Please solve it now.
Okay, sir.